So the traveling comedian problem is, well, I explain where this title came from and why on earth I'm talking about this somewhat bizarre topic. If you want to go and find out all the resources for this, my GitHub account has everything available. And it might well have the video of this talk there as available. We'll have to wait and see. Okay, so Dave Gorman is a comedian. He's a British comedian. He's been doing loads of tours for years. He is actually a mathematician, although he dropped out of doing mathematics. And he's done a variety of tours around the UK. And very famously, he says that he doesn't book the venues that host his gigs. They book him. So I thought, hang on, if someone just waits for all these theatres around the country to book it, how does he schedule which one he goes to when? It looks as though he's sort of given up control of it. So, but the very first tour he did, which is back in 2009, he actually cycled between the venues, but I'll come to that in just a moment. All right, so we're going to talk about Dave Gorman's UK tours. We're also going to talk about GG Animate and how you can just do some straightforward maps using the GG plot package. Now, if I want to give it a fancy name, it's Monte Carlo simulations. No, I'm not. I'm just doing brute force simulations and just grab the best result possible. So you're not going to see clever stuff here today. I really assure you of that. So you're not going to see elegant code in today's talk, right? I'm just managing your expectations to a sensible level. You're not going to see all the trial and error stuff trying to get GG Animate to do what I wanted it to do, because there's umpteen different things, and I ended up just lumping down on just one feature. So there's many more things you're going to see beyond that. It's all the traveling comedian problem is based around sort of graph theory, in which you've got some really clever algorithms. You're not going to see any of them. And you're not going to see Dave Gorman. You've got me instead. So a little bit about me, just beyond what was already said. I started using R back in 2017. I used to be a secondary school maths teacher, and I went, no, I'd like to be a statistician and do sort of data science. So that then got me the job as a senior data analyst last year, since July of 2023. But I have done talks at the Edinburgh Group in that last 7 or so years on those various topics, and Mike was silly enough to allow me to come along and talk to you again today. So let's just go on. Now, another thing you need to know is I write questions for statistical exams. And one of the statistical exams I write questions for involves getting large data sets and writing a sort of report and then asking our candidates questions about that report. And this data set, which is being featured in today's talk, I desperately tried to write it in a way that made sense for candidates, but it just didn't work. So this is nothing more than salvaging hours and hours of work that was otherwise going to go to waste. So it's like a phoenix from the flames. This is recycled salvage data. The title of the talk was Traveling Comedian Problem. It's a play on the traveling salesman problem, and Wikipedia says that the traveling salesman problem is, given a list of cities and the distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns the original city. All right. Now, what we're going to look at is basically that problem, but without the returning to the original city. Dave Gorman's going to do his various tours, and he doesn't have to do a final show in the same place that he started off. This has been around since the 19th century by an Irish and British mathematician. They got some really clever stuff. We're not going to include that, but that's the sort of a parody of the title here. So I mentioned that Dave Gorman cycled around back in 2009. This was his poster. He did a tour called Sit Down, Pedal, Pedal, Stop and Stand Up. He, for a long period of time, cycled from John O'Groats to Land's End to John O'Groats to get the right way around, and stopping at various places along the way. And sometimes the venues were just like the pub, the village pub, because he was just so far from civilization at that time. That was his first tour, as I say, from back in 2009. He then did another tour, following up that, shortly after. Dave Gorman's PowerPoint presentation, very similar to what we're doing here. We just have a PowerPoint in the background and tell you lots of stories about it. He then did Dave Gorman Get Straight to the PowerPoint. Then it was Dave Gorman with Great PowerPoint Comes Great Responsibility Point. That tour got extended. Then he did Dave Gorman's PowerPoint to the People. That tour got extended as well. So we've got 7 posters here, but he's actually done 8 tours. I just couldn't find the 8th tour poster, but I do have the information in it. So this is the backdrop. This is the data set. And when you put it all together in Excel, I know it's a dirty word, but Excel, I did briefly use it. We've got all the tours numbers, so 1 through to 8. This list is a whole lot longer than what you're seeing here. The actual date of the gig, the town in which the gig took place, the theater, and then the postcode. And the postcode at the moment has got spaces between them, but I'm going to strip those out later on. So that was my starting data set. But if I'm going to try and figure out how far he travels between each gig, I need to know the longitude and latitude of every single postcode, all right? So I'm going to source that in a minute. So the packages I use in this whole process, just listed up here, you might recognize a few of them. The ones which the ggAnimate package uses is that one, ggAnimate, and GIFSKI. We'll talk about those in a moment, but other than the rest are all fairly straightforward ones. So I load in the information from maps, and within ggplot2, there's the map data command. Now, there's already a bit of an inconsistency, because when I started this off, I thought Dave Coleman just did his gigs in venues in mainland UK. And then I discovered he'd done some in Dublin and in the Channel Islands. All right, so even though it's called mainland map, I've had to include places which are clearly not in the mainland. I do apologize, I didn't bother renaming the variable for my code, all right? But you can just pick bits and bobs of the British Isles and just add them into a map. And I also found that the postcode data set which I could source, and there's information on the GitHub for where you can get it's got millions of rows of every single UK postcode and its longitude and its latitude. But there were 3 places that Dave Gorman did a gig in that weren't on that list. So I had to manually find out what the postcodes were and the longitude and latitude. And so basically this big long list of about 1 million or so postcodes, I stripped out all the blank spaces and the missing data, replaced all the spaces, and then row binded the postcodes extra. So I've now got one big data frame of postcodes, longitudes, and latitudes, all right? So I've got my Excel spreadsheet of all his tours with all his postcodes, and I've got this other one with postcodes and longitude and latitude, and so I just do a left join and a bit of tidying up. So everything is now in one place, everything I need to be able to do some graphics from. And this is the first graphic. This is the route that Dave Gorman did going from Land's End to John O'Groats. And we're going to see this code a few times, so let me just talk through and make sure you're all happy with it. So we're using the ggplot package just to create this. The geom path in the color gray, that effectively gives us the outline of the British Isles. We then put on the red points using our tours data frame of the actual locations he did the gig. We then superimposed on top a nice sort of blue path, so you can see the route that he took, so it wasn't just a random dots over the package, and a bit of tidying up here. Now, it's got a facet rat here because this is just one of the 8 tours, and there are all 8 tours that he did. All right, so you can see that tour 1, it's a breeze, and the rest, chaos, or so it would appear, all right? And so what we're going to look at is, I want an animated version of this. I don't want to see just, because it's really hard to see where did he start, where did he end. You just know he's traveling up and down, north, south, east, and west, and going to pieces. Now, bit of audience participation. Which tour, obviously not tour 1, because that's a very efficient tour, which of the other tours is the most inefficient, do you think? I'll shout out a number from 2 to 8. 3. So 3 looks fairly inefficient. We'll be able to quantify that shortly. Any other nominations for the most inefficient tour? Say again? 2. 2's pretty bad. Yep. 4. Exactly. We could just name all numbers from 2 up to 8 if we wanted to. But as you can see, it's really quite hard to spot from here. So this is when the ggAnimate package comes in. So the ggAnimate documentation, it's just a bit rubbish. It didn't tell me what I needed to go. So I needed to go to other people's websites. So I found this one from Catherine Good on that place, and she had lots and lots of examples. If you do this code, it does this. If you do this code, that's what I like. I want like lots of examples. If that doesn't float your boat, Data Novia, there was another place where I got information from. So those are the best places, way better than the vignette that comes with the ggAnimate package. Okay, so how do I turn my map into an animated one? I just add 2 lines of code, one at the very top and one at the very bottom. All right, so this is everything you saw before, all right, unchanged. And at the very top, I choose to store this ggplot object in tour routes, all right, a little variable called tour routes. And way down at the very bottom, I've got a command that says transition reveal. And what this effectively is doing is it's going to sort of, what parameter are you going to use to sort of what's the word? To reveal, there we go. What's the parameter you're going to use to reveal each frame as the animation goes on, all right? And effectively the order of the tour. So day 1 of the tour, day 2 of the tour, day 3 of the tour, and you'll actually sort of see all these points map out bit by bit, all right? So it looks disarmingly straightforward that all you needed is possibly that 1 line of code. There's a little bit more. You then go to the ggAnimate package and you use the animate command. And what it does, I'm sure you can read it yourself, but it basically takes that graphic and turns it into a GIF, all right? And the code for doing that is that the tour routes thing, which you saw a moment ago, you can specify how many frames you want in total and how many frames per second. And you can set it up so if you had it as a GIF, it would just play again repeatedly rather than just playing once and then stopping it. And there are lots of other factors you can do. But I just decided to go for those ones today. And this anim save then just saves that GIF to your local file, and I put it into a folder called output. All right. So with that all in play, I then had a GIF file. Because of what I wanted to do with it, I wanted to turn it into an MP4. So there's a nice free website for converting GIFs to MP4s without restrictions or branding. So that might be useful for other things. And so what we're about to do, we're now about to see the animation. Now we're going to play it through once or twice, because at the moment you'll just be watching things. You'll see a lovely smooth path there, but I invite you to just pick one of the other plots, possibly the one you shouted out a moment ago. And let's just see what happens. We'll play this once or twice, but here is the animation. And in the top, you can see the days counting off. This is Dave Gorman's tours. It's a little bit hypnotic. I need a soundtrack, I know. And there we go, 42 days. All right, let's just, and you can see that some of them are just bouncing around left, right, and center. And Tour 2 did do a fair amount of traveling. Tour 4 was a bit chaotic, but we'll just see it again so you can watch another, oops, you can just want to watch another map different from the one you saw a moment ago. Because I spent so long creating this, I want people to watch it as many times as possible. Now you'll notice that when you get to about day 35, some of the red dots disappear. And then when day 42 happens, they all appear at the very end, because some of the tours were different lengths, and I couldn't quite find how to get the red dot to stay. So it's certainly not perfect. There's room for improvement. There's your homework, all right? So I still don't have a sense of which one's the worst. I visually have a sense of there's chaos happening, but which one's the longest and which one's the shortest. So what I decided to do is a few calculations. What's the mean daily distance traveled between two venues for each of the 8 tours? All right, so code I've done. I'll not spend too much on this, but effectively I get all my tours, I arrange them in date order, and then I work out the distance using there's lots of different ways of finding distances between longitude and latitude points. So I chose the Haversine, I can't remember why. The divided by 1,000 just turns meters into kilometers. That's just a scaling factor. And it's just effectively comparing the distance between a longitude and latitude and the next longitude and latitude in the list, which is fine because we put the list in order. And then what I did is with all those distances, I then summarized it to get the mean distance. And all this little thing is doing is just rounding the nearest whole number. When you run that and you get all the different mean daily distances for each of the 8 tours, you get this table. And so you can see Tour 1, the one when he cycled around UK, he had about 55 kilometers on average to cycle each day. Tour 2, that was one of the nominated, that was a whopping over 200 kilometers on average between consecutive. He must have spent his whole day just in a car or a train. And they're definitely the 2 outliers, the smallest and highest. All the other ones, he's traveling around about 100 and whatever kilometers on average per day between different gigs. All right. So let's find the best route. Now, there is some shocking code up here. All right. I'm just going to admit it straight out. All right. There's a for loop. I'm so sorry. All right. But when I write for loops, I'm going to go to a better place, but it's sort of how I started off learning programming. And there's some really dubious practice here, which I found out later on you really shouldn't do. But let's tell me a bit later about it. We're going to do 100,000 trials, and basically what it's going to do, it's going to get for each tour, it's got all his gigs in the current order, and it's just going to randomly mix them up and work out the mean daily distance and record that, and then randomly mix them up again, record, and it's just going to do that 100,000 times, and hopefully somewhere in there will be a route that's better than the one he did. I told you it was brute force and ugly. All right. So there's that code from before working out all the stuff. And I've created a couple of empty lists. And I've got this variable I counting up from 1 to 100,000. And I thought, because I was able to do it in other programming languages I knew, I could just basically make that list get 1 bigger every single time. So this thing called routes list is going to be 100,000 long, and each element of that list is going to be a copy of a data frame. So I'm going to have 100,000 data frames stored in a list that just gets longer and longer and longer. This apparently is bad practice, all right? But it worked. It gave me the job that I wanted, and I thought I need to do this more elegant, otherwise they'll laugh me out of the room. So what I did is I just tidied it up a bit, all right? So instead of having for loops, I designed a function which would be able to be fed into the per map command, and I don't have any of these lists that just get growing and growing and growing. So I sort of got rid of two bad things in favor of something that's hopefully appreciated a little bit better. Not totally brilliant, but still a little bit better. So running all those simulations 100,000 times then gave us this graphic here. Now let me explain what's going on here. The red line on each graphic is the mean daily distance of the tour that he actually did. And the histogram of points, and there are 100,000 points in each of these graphics, are all the mean daily distances from all those randomized routes to see if any of them were better. And I think you'd agree, he pretty much optimized Tour 1. Tour 2, well, there were some randomly generated routes that were shorter in mean daily distance than the one he actually did. And if you want to have a sense of how much of the distribution is to the left of that point, there's about 7%. So of my 100,000 simulations, about 7% of them were better than the tour he actually did. But the other tours, despite the chaos that you saw, are actually not that bad. I mean, there's a few which are shorter, but I only ran the simulation for 100,000 times, and it was just literally just throwing mud against the wall. There was no elegance to it. But look at Tour 8. We can seriously improve Tour 8, all right? That was the one that was the extension of the final run, and, you know, he had very little control over it. So what we're going to do is we're going to focus on Tour 8, and we're going to find the dot that's furthest to the left. It's probably so small we can't see it. And we definitely want to try and improve upon this 177 average kilometers per day to something that's just above 100. So the little bit of code that gets that is I pick my tour of interest. I'm going to go for Tour 8. I need to find the optimal tour simulation, the number. Which tour was it? Was it number 1, number 2, number 3, number 4, number 5, all the way up to 100,000? Sorry, which simulation gave me the best that? So I find out which tour has the mean daily distance that's equal to the minimum mean daily distance. All right, so it's going to look through all 100,000 and find the shortest one. That will give me a number between 1 and 100,000, and then I'm going to pluck that individual tour route from the routes list, the one from before with the bad code, and draw a graph of it. So what you're about to now see is on the left with Dave Gorman's original Tour 8, and on the right, Tour 8.1, a better tour, according to that complete random. And just numerically, you can see we have improved. He does do a less average, but it's by no means optimal. So here we go. Here's the animation of Tour 8.1 against the original. You'll hopefully appreciate this one's better, but there's still room for improvement. Here we go. You're probably thinking, oh, we could have done that a little bit better at the top. There's still a bit of backtracking. And there we go. That apparently is better than that. Could have saved them a whole load of petrol. So with that all done, I thought, well, there's no point having the route and an animated without an updated poster, all right? So this was the original poster, and you can see he started in Loughborough, Skegness, Birmingham, Swindon, all right? And then he ended in Sheffield and Bath. But that's the original tour. If we change them all, this is what the venue should be. There we go. And if we just go back, it's really some interesting differences here. So Skegness and Swindon, he does Skegness and Swindon near the beginning, and then Skegness is the starting point and Swindon's the end point. And there is one venue on one date that doesn't change. I'm just going to flick back and forth between them. Can you see which one doesn't change? He would have stayed in the same venue, back and forth, back and forth. Who can spot it first? Okay, whoops, hang on, it's going too far. Can anyone spot it? Back and forth. Sheffield, there we go. Sheffield, 10th of December is where you would visit regardless of which tour route you went. All right? So there we go. That's That's the data that I couldn't turn into an exam question, but hopefully turned into something a little bit entertaining. So I will happily take any questions on that madness in a moment, but a small advert. I am part of the Royal Statistical Society Edinburgh local group, and we are running an event in September that Chia was a mystery guest at last year. So if you want to quiz her on what this involves, she'd more than happily answer it. But effectively, I'm looking for anyone in this room who's a data scientist or a statistician who wants to be a mystery guest for an evening. And last year we had about 10 mystery guests, and lots of school pupils, 5th years, 6th years, and undergraduates came along and just quizzed you for 10 minutes, and they had to figure out what you actually did for a job. All right, and then once they'd figured out what you did for a job and you waxed lyrical about how much fun it is, they then went on to the next person. It was like a bit of speed dating. All right, and by the end of the hour, there's about 40 or 50 students had a chance to talk to 10 people who inspired them, and we had people from, the cheer specialists, and we had forestry experts and cancer research. The weirder the better, to some extent. And you could be a mystery guest on that evening. So if the QR code doesn't work for you, RSSE is the Royal Statistical Society Edinburgh.nhost. That's my website.uk, and there's a place there you can sign up to register. And if you have students at university, they can register to come along as the guests to do all the quizzing. So I'm going to leave that up there so that there's as much visual impact as possible. But I'm now open to any questions you might have on the silliness you just listened to for the last 20 minutes. Hi. No, but I'm thinking of. That's another reason why I'm recording it.